Dear children, welcome to the YouTube channel H2O Chemistry. I'm Satya Narayanan, your chemistry teacher. In this video, we are going to talk about the topic Avogadro's law or Avogadro's hypothesis. Before we start this session, I would strongly recommend you have to watch the concept of mole. So then only you can understand this concept much better. Now we will talk about the concept of mole. It's just like a revision. So 1 gram atom or gram atomic mass of any element is equal to 1 mole. For example, 16 gram of oxygen element is nothing but 1 mole. Similarly, 1 gram of hydrogen, 14 gram of nitrogen all are equal to 1 mole. The gram molecular mass of a molecule is also equal to 1 mole. For example, 32 grams of oxygen molecule is also 1 mole. Similarly, 2 grams of hydrogen molecule, 28 grams of nitrogen molecule, all we can say 1 mole. So I conclude gram atomic mass of an element or gram molecular mass of a molecule is equal to 1 mole. So this concept you should be very familiar. And one more information, 1 mole of any substance contains 6.023 in 10 to the power of 23 particles, or nothing but Avogadro number of particles. So what is this 6.02 in 10 to the power of 23 particles? It's very simple. If I have 1 dozen pencils, I have 12 pencils, right? Similarly, if I have 1 mole of a substance, I have 6.023 in 10 to the power of 23 substances. That's what we have to understand. It's just a number. It's a very huge number. It's not like a dozen. It's a very huge number. And one more information, this mole concept really talk about microscopic particles, especially atoms, molecules, ions, electrons, protons, neutrons, etc. We are not talking about any macroscopic particles like pen, pencil, or TV or laptop, whatever. So this mole concept means we are talking about 6.023 in 10 to the power of 23 particles which are at atom level, remember. For example, if I have a 32 grams of oxygen molecule which contains 6.023 in 10 to the power of 23 molecules of oxygen. Similarly, 2 grams of hydrogen molecule contains 6.023 into 10 to the power of 23 molecules of hydrogen. So, specification of a particle is important, whether it is an atom or molecule. So, if I have a 16 gram of oxygen, which contains 6.023 into 10 to the power of 23 atoms of oxygen, that's what we have to understand. Come to the next one. Gram molecular volume. So gram molecular volume is otherwise called as a molar volume at STP. The value is 22.4 liters. What is this? 1 mole of any gas occupies 22.4 liters at standard temperature and pressure. STP means standard temperature and pressure. So 22.4 liters is what you have to understand. So if I take gram molecular mass, for example, 32 grams of oxygen molecule is gram molecular mass. So this exactly occupies 22.4 liters at STP because it is a gas, remember. So all the gas, if you take the gram molecular mass of a gas and refill in a container, you have to weigh 32 grams of oxygen in a particular vessel, the particular electronic balance. And if you transfer that content into a particular vessel and which exactly occupies 22.4 liters at standard temperature and pressure. So any substance that occupies or any gas that occupies 22.4 liters at standard temperature and pressure is called 1 mole. I conclude. So gram atomic mass or gram molecular mass of a substance is equal to 1 mole. 1 mole contains Avogadro number of particles. If it is a gas which occupies 22.4 liters at standard temperature and pressure. Let us go to the next concept called Avogadro's law. Look at this. Imagine that all these 4 boxes or vessels. The vessel volume is constant. The volume of the vessel is constant. In the first vessel, I have taken 12 gram of carbon, which is nothing but gram atomic mass of carbon, which is equal to 1 mole. Similarly, 32 grams of oxygen molecule, which is nothing but gram molecular mass of oxygen, which is equal to 1 mole. So 28 grams of nitrogen molecule, nothing but gram molecular mass of nitrogen, which is equal to 1 mole. Similarly, 17 grams of ammonia molecule, which is nothing but gram molecular mass of ammonia. All these vessels are equal to 1 mole. Remember, that's what the 1 mole is. Now, 12 grams of carbon contains 6.023 into 10 to the power of 23 atoms of carbon. Similarly, 32 grams of oxygen contains 6.023 into 10 to the power of 23 oxygen molecules. Similarly, 28 grams of nitrogen molecule contains 6.023 into 10 to the power of 23 nitrogen molecules. 17 grams of ammonia molecule contains 6.023 into 10 to the power of 23 ammonia molecule. And if it is a gas, we know very well that oxygen, nitrogen, ammonia, all are gases. So this 32 gram of oxygen exactly occupies 22.4 liters at STP because it's a gram molecular mass. Similarly, 28 grams of nitrogen molecule occupies 22.4 liters at STP. As like this, right? 17 grams of ammonia molecule occupies 22.4 liters at STP exactly. So what you have understood from this? Look at this clearly and carefully. 22.4 liters at STP occupies 6.023 in 10 to the power of 23 particles, right? In all these cases. So if it is a gas, 32 grams of oxygen molecule occupies 22.4 liters, but which contains 6.023 10 to the power of 23 oxygen molecules. Similarly, nitrogen, 28 grams of nitrogen occupies exactly 22.4 liters at STP, but has 6.023 into 10 to the power of 23 nitrogen molecules. Similarly, in the ammonia case, 20.4 liters at STP contains 6.023 into 10 to the power of 23 ammonia molecules. So look at this. Is there any correlation between the volume and the number of particles? Yes, that's what the Avogadro rule is. The Avogadro has found out that there is a relation, strong relation between the volume of a gas and the number of molecules. Number of molecules. That's what his hypothesis is. It is see this concept 22.4 liters. All the 22.4 liters they have equal number of molecules. So equal volume of all gases contains equal number of molecules under similar condition of temperature and pressure. That's what the law is. Very simple. So 22.4 liters contains this. So equal volume contains equal number of molecules. That's what the law is. Under similar condition of temperature and pressure, that's what we call STP. What we call STP. So this is a very simple idea. Equal volume of all gases contains equal number of molecules at STP. This is a very simple we can quote. So let us take an example. By going to the next slide. Look at this. The Avogadro is an Italian scientist. In 1811, he has proposed this theory or hypothesis. Amedeo Avogadro framed this hypothesis, I told you already, based on volume and number of molecules under different conditions. Based on that, he has framed a law, which is nothing but equal volume of all gases under similar condition of temperature and pressure contains equal number of molecules. Now, look at this balloon. The balloon has a gas inside. One is filled with hydrogen, another one is filled with oxygen, another one is filled with nitrogen, another one with ammonia. Now, the volume of this balloon is exactly equal. If the balloon volume is 1 liter, the volume of the balloon is 1 liter, all the volume of all the balloons, the volume is 1 liter for all the balloons. If the first balloon contains 5 molecules of hydrogen, the second one also contains 5 molecules, third one contains 5 molecules, fourth one contains 5 molecules, right? So that's what exactly we're talking about, equal volume. So all the balloons have equal volume. The balloon's volume is equal. The size of the balloon is equal. That means the volume is equal. They have a same volume. Remember, equal volume of all gases contains equal number of molecules. So if this contains one molecule, this balloon also contains one, this balloon also contains one, this balloon also contains one molecule. That's what Avogadro law prediction is. Yeah, based on this, only we have found out that value 6.023 in 10 to the power of 23. To honor him, we have given this name Avogadro number. Remember, and each balloon have the same volume. Hence, each balloon contains equal number of molecules, provided all these measurements are measured at same condition of temperature and pressure. That's what. So what we can finally conclude: volume of a gas has some relation with number of particles. So he said volume of a gas is directly proportional to the number of molecules. V is directly proportional to N, where V is volume of a gas and N is the number of molecules present in it. So if the volume increases, number of particles will increase. If volume decreases, number of particles will also decrease. That's what the simple idea we can propose. Now let us come to the example or idea how to solve this example. So under same condition of temperature and pressure, if you collect 3 liters of oxygen and 5 liters of chlorine and 6 liters of hydrogen, so remember, under same condition of temperature and pressure, yes, the condition is maintained. 3 liters of oxygen, 5 liters of chlorine and 6 liters of hydrogen. So which has highest number of molecules? That is the first question. Which has highest number of molecules? When the volume is increasing, number of molecules will also increase. So find out which has higher mass. Exactly. 6 liters of hydrogen has a more volume when compared to other two. So the 6 liters of hydrogen contains more volume, more number of molecules, more number of molecules. Come to the second one, which has the lowest number of molecules. Yes, if V decreases, N decreases. Very simple. So 3 liters of oxygen contains less number of molecules. I hope this video will be very helpful to understand Avogadro's hypothesis or Avogadro's principle. In our next video, we will learn application of Avogadro's principle with a detailed manner so that each one of the applications we can understand very easily. Subscribe for more videos. The chemistry made easy here. Thank you so much, my dear children. See you. Bye-bye.